geostationary Earth orbit. What is the height of satellite? Low Earth orbit. What is the altitude of the satellite? What is the height of low Earth?
600 to 1000 kilometers.
Okay, very nice. And how many satellites we can launch in low Earth orbit? How many satellites?
40 to 80.
Okay, very nice. And for medium Earth orbit, what is the height of medium Earth orbit satellite?
5000 to 12,000 kilometers.
Okay, how many satellites we can launch?
8 to 20.
So 8 to 20. And what is geostationary satellites? What is the height of this?
35,800 kilometers.
35,800 kilometers. How many satellites?
3.
Only 3. Keep in mind, only 3 satellites we can launch in geostationary satellite. Okay. Yesterday we have seen this types of satellites, and today we'll start the next point of this unit, that is launchers. Point number 7 is launchers. The launchers is nothing but what? Whenever you are going to launch a particular satellite, that is called as launching. A particular rocket has been launching from Earth station to satellite, that is called as launch. In this, the launchers, the historic is there. Previously, they are going to launch some of the satellites. The name of those satellites are Satellite Launch Vehicle, Augmented Satellite Launch Vehicle, that is ASLV. They are operated on polar satellite and geostationary satellite launch vehicle. SLV is nothing but satellite launch vehicle. And what are the features they are using? The GSLV, that is geostationary satellite launch vehicle, that is MK3, and RLV TD. How many satellites they are going to launch from initial stage? That is, first they are launching SLV3. That is, the height of this satellite is 22.7 meters. What is the payload? That is, the weight of this particular satellite is 17 ton, 17 ton. And the propulsion is all solid. There is no liquid in this. And what is the payload? The weight of this mass is 40 kg. And the orbit is low Earth orbit. It is the started launching in low Earth orbit. And similarly they are going to launch the other satellite, that is ASLV. The ASLV is, that is more than SLV, that is Augmented Satellite Launch Vehicle. The height of this satellite is 23.5 meter, lift, that is 39 ton, propulsion all solid. It is also all solid, and payload of mass that is required is 150 kg, and the orbit is of low Earth orbit. It is, these two are orbiting in low Earth orbit. The next satellite is of PSLV XL. Next satellite is of PSLV XL. The height of this satellite, however, they are goes on increasing, goes on launching the satellites. The height is increases, weight is also increases. Height is 44 meter. The lift, what the weight of this satellite is 320 ton. It is combination of both solid and liquid, and it is going to carry, the lift is of 1860 kg, 1860 kg. It is revolving in sun synchronous polar orbit. Sun synchronous polar orbit is nothing but in a 90 degree in shape. That is going to revolve around the Earth in 90 degree in shape. And now next satellite, that is GSLV. Nowadays they are going to launch GSLV satellite, not a PSLV. For low Earth orbit they are going to launch PSLV, and for high Earth orbit they are going to launch GSLV. The next satellite is of GSLV MK2. Here it is PSLV XL. PSLV is different, GSLV is different. Polar and geosynchronous. GSLV MK2, height of this satellite is 49 meter. What is the lift? Weight of the satellite is 414 ton. It is a combination of solid, liquid, and cryogenic. 3 parts are there. One is solid part, one is liquid part, one is cryogenic part. That is the top of this satellite is cryogenic. What is the lifting weight of this is 2200 kg. It is going to lift 2200 kg of the mass. And orbit, it is going to launch as geosynchronous transfer orbit. It is in a polar orbit. It is in a polar orbit. And again, we are going to increase the satellites launching. That is GSLV Mk3. The name of this satellite is GSLV Mk3. The previous is GSLV Mk2. And next is GSLV Mk3. Height is 43.43. The height is reduces and lift increases, weight increases. It requires again the solid, liquid and cryogenic. And it is going to carry more weight, that is of 4000 kg as compared to GSLV Mk2. It is going to carry the more weight as compared to GSLV Mk2. It is also orbiting in geosynchronous orbit. All these satellites are going to orbiting in the low Earth orbit and the medium Earth orbit. This is the sum of the introduction of launchers. And what actually, this is very important, what actually is a satellite launch vehicle? In short form, it is called as SLV. What exactly is a satellite launch vehicle? See that diagram. What is satellite launch vehicle? Definition is the rocket that is used to launch a satellite. A rocket that is used to launch a satellite is called a satellite launch vehicle. Whatever the rocket is there, that can be used to launch a satellite from Earth station to space. That is called as satellite launch vehicle. A launch vehicle is made up of several different segments or stages, with each stage playing a different role. I will explain what the stages are. Here it is, we are seeing the number of stages. Here there is a satellite is there. The first stage is below side of the satellite. To lift from the earth, for lifting that, they are using number of rockets. To lifting from earth to sky, we are using the first stage. And when it is reached to the sky, to reach the space, we are using the second stage. And after reaching the space, and it is reached to the specific environment, to start rotating around the earth, that is your upper stage. And the fairing is nothing but what? It is like a feathers. It is acting like a feather. It is going to protect your the particular satellite. The main satellite, the machine of the satellite is going to protect, that is called as the fairing. And the satellite is present inside that fairing. These are the sum of the stages or the segments we are using in satellite. We'll see briefly what is the function of first stage and what is the actual function of second stage and what is the actual function of upper stage and what is the function of fairing and what actually the satellite is going to do. The first stage of the launch vehicle contains a fuel. What it contains? It contains a fuel tank. The first stage, this one, the first stage, below side of this, it contains a fuel tank that is needed to lift the satellite for lifting from Earth to some of the sky. That is the lift the satellite and launch vehicle off the ground, to lift from the ground. That is, we needed a first stage. It contains a fuel tank into the sky. And the rockets have to be very powerful. Whatever the rockets are present in first stage, they are very powerful because a launch vehicle at a lift-off weighs hundreds of tons. It has to carry more and more millions and hundreds of tons. So we require the higher and higher rockets. After that, what happens? After all the fuel has been used up, once it is lifted from Earth to the sky, whatever the fuel present in that particular rocket, once all the fuel has been completed, it has been used up, that is to be burnt Immediately that is burnt, it is separated from the satellite. That is separated from the first stage. That is, all the fuel has been used up. The first stage is no longer needed. The first stage is no longer needed and it is breaks off and fall to the ground. First stage is over. It is the actual function of first stage is to lift the satellite from Earth to the sky. That is only the function of first stage. What is the function of second stage then? The second stage contains smaller rockets that ignite after the first stage is finished. When that is going to start second stage? Once the first stage has been completed. After completion of first stage, second stage will start opening. First stage is finished. The rockets of the second stage, again the rockets, the fuel tanks are present in the second stage. The rockets of the second stage have their own fuel tank. The second stage is used to send a satellite. See the point? The second stage is used to send the satellite into the space. What is the function of first stage? It is to lift the satellite from Earth to sky. Second stage is to take the satellite from sky to the space, like the first stage does. It breaks off after all the fuel has been used up. Whatever the fuel present in the second stage, if once the fuel has been completed, it is used up, burns up in the Earth atmosphere and it is falls back. And it is first stage is completed, it is burned off. Second stage is completed, it is burst off. In the first stage, it is reached to the sky. Second stage goes from sky to the space. The function is of third stage, that is of upper stage. Upper stage, the function of upper stage is the upper stage of the launch vehicle is connected to the satellite itself. It is to be connected to the satellite itself, which is enclosed in a metal shield. Whatever the upper stage is connected to the satellite, it is to be enclosed in a metal shield called as a fairing. These two feathers, it is looking like a feather shape. That is the two hands, it is looking like two hands. It is third stage is connected to the satellite itself. It is to protect the satellite. For protecting the satellite, they are using a fairing. That is called a fairing. The fairing protects the satellite while it is being launched and makes it easier for the launch vehicle to travel through a resistance of Earth atmosphere. Once it is reached to the space, after that space, the satellite has to move to the particular orbit of the Earth. It has to move to the particular resistance of Earth atmosphere. That function will be done by the Earth upper stage till the satellite has reached to the particular orbit, reached to the particular path. Next, that is the fairing splits apart. Once it is reached to the Earth atmosphere, once it is reached to the nearer to the its orbit, its path, the fairing splits apart once the satellite is above the Earth atmosphere. Once it is reached to the Earth atmosphere, the third stage is burns up in the Earth atmosphere. And the rockets of the upper stage fire after the satellite is in space. It fires after the satellite is in space and put the satellite in the exact space spot. It is going to put the exact spot where it is needed. While launching the satellite, the scientist has to point out the orbit, particular path where it has to reach. Till now, the first stage has completed, second stage has completed, and the third stage has to reach to the particular orbit. That is actual the function of first stage, second stage, and upper stage. Next, once the launch vehicle is out of the Earth atmosphere, the satellite separates from the Earth stage. It separates from the Earth stage. The satellite is then sent to the transfer orbit. Transfer orbit is nothing but where it has to start revolving. That is to be transfer orbit that sends the satellite higher into the space. Once the satellite reaches its desired orbit height, its solar panels, once it is reached the particular path of that satellite, it start opening solar panels, whatever they are mounted at the time of manufacturing the solar panels, it start opening, and the communication antennas, it is also start opening, which had been stored away during the flight. During the launching, they have stored the solar panels and the communication antennas. And once it is reached to the particular path, it start opening the solar panels and it start opening the communication antenna, and it start giving a signal to the particular Earth station to the public. Then the satellite then takes its place in the orbit with other satellites. There are more number of satellites are revolving around the Earth, Moon, and the Sun. It is start revolving around the other satellites and is ready to provide communication to the public or the Earth station. This point is very important. You have to note that we use two types of launch vehicles. One is Polar Satellite Launch Vehicle, PSLV. You are launching Polar Satellite Launch Vehicle, that is PSLV. Second is Geosynchronous Satellite Launch Vehicle, that is GSLV. PSLV and GSLV. The PSLV has 4 stages. PSLV has 4 stages using solid and liquid propulsion system. There are 4 stages. First is solid, next is liquid. Whereas GSLV has 3 stages. One is solid, liquid, and cryogenic stages respectively. This is how exactly the satellite is going to launch. We'll see one video with this. I'll show you one new video. See this, how they are going to launch the satellite. Is it visible?
Yes, sir.
Yes, sir.
See this video. The first stage is finished. It is separated. Second, 2 separated. Third, pairings separated. Third stage is over. So this is your actual satellite. You start opening your signal antenna, communication antenna. Solar panels. It takes its path. orbit. Started revolving. Geostationary satellite. Okay. Got it? Got it, everyone? How they are launching the satellite?
Yes, sir.
Yeah. They are using the 3 stages, first stage, second stage, and upper stage. To protect the particular satellite, they are using the fairing, and whatever the satellite is protected inside the fairing, once it is reached to the desired orbit, the desired path, and it start opening a particular antenna which is mounted at the time of manufacturing, start opening the solar panels and communication antennas, start giving the signal to the Earth station. This is the function of satellite launch vehicle. There are mainly 2 types of satellite launch vehicle. One is Polar Satellite Launch Vehicle, that is PSLV. PSLV is Polar Satellite Launch Vehicle. These satellite launch vehicles are launched by ISRO. ISRO is Indian Space Research Organization. It is started launching in low Earth orbit. It is used for remote sensing and Earth imaging, to take the images, to take the snapshot of the Earth, that can be used a PSLV. To cover a whole Earth, it requires 4 engines. It requires 4 engines. 4 engines is divided into 2 parts. The first and third part is solid fuel, and second and fourth part is liquid fuel. It is having 4 engines. A first and third stage is of solid fuel. Second and fourth is of liquid fuel. It is very reliable. It has to be at maximum of the age is of 22 years. Actually, the mission used is in Chandrayaan-1. They are launching for Chandrayaan-1, that is PSLV, Polar Satellite Launch Vehicle. The second is a Geosynchronous Satellite Launch Vehicle, that is GSLV, Geosynchronous Satellite Launch Vehicle. This geosynchronous satellite launch vehicles are mainly used for communication system, for communication satellite to the orbit. Communication satellites. These are all communication satellites. It is giving for the signal by using telephone signals and radio signals. Used for telephone signals to get the radio signals. It maintains fixed position in orbit. Means what? It is similar to that of your geostationary orbits. It is similar to that of your geostationary satellite. It is to maintain the fixed position in the orbit. That is a function of GSLV. Next point is the speed of Earth is same as that of revolution of satellite. The speed of Earth is same as that of revolution of satellite. So it is rotating around the Earth in stationary orbit. That is called as the posigrade. You have seen in the previous lecture. Prograde and posigrade and retrograde. Posigrade is both are revolving in same direction. Retrograde is the one is Earth is revolving in one direction and the satellite is revolving in opposite direction. That is what? A retrograde. GSLV engines, 3 stages only. First stage is of solid, second stage is of liquid, and third is of cryogenic. And this cryogenic technology is one of the advanced technology used in most of the 6 countries. Used in the 6 countries, that is, first is US, United States of America, Russia, France, India, China, and Japan. They are using most in 6 of the countries. They will ask you the question, you have to give the difference between, you have to give different or comparison between PSLV and GSLV. Write the comparison between PSLV and GSLV. PSLV, the weight of this payload, that is weight is of 1750 kilometer, and weight of this GSLV is 2500 kg. The elevation angle, that is inclination angle or the height, that is 600 to 900 kilometer, and for this 36,000 kilometer, it is similar to that of your geostationary. Lightweight satellites in lower orbit, heavyweight satellites in higher orbit. Higher is nothing but the geostationary orbits, that is higher orbit at the space. 4 stages, one is solid, liquid, and fuel engine. 3 stages, one is solid, liquid, and cryogenic. We'll see detail the difference between, that is comparison between PSLV and GSLV. Write some of the comparison. Make 3 columns. One is parameter, one is PSLV, one is GSLV. Generation, which generation it is launched? It is in 3rd generation launch vehicle, PSLV, and GSLV is of 4th generation launch vehicle. And the type of satellites we are using, which type of we are using? Deliver the remote sensing satellites to the sun synchronous orbit. It is to deliver the communication satellites. Not to take the snapshot of Earth station, we are using PSLV, and for communicating any signal, that is we are using GSLV. Number of stages we have seen, 4 stages, that is 2 solid, 2 liquid, PSLV. And in GSLV, only 3 stages are there, one is solid, liquid, and cryogenic stage. Variants, types. Variants is nothing but types. PSLV types are PSLV-G, PSLV-CA, PSLV-XL. And GSLV types, GSLV-MK1, GSLV-MK2, GSLV-MK3. What is the weight? Lift, it is going to lift minimum of 230 to 320 tons. That is of PSLV. And in GSLV, it is going to lift a weight of 400 to 600 tons. It will lift the weight of 400 to 600 tons. Height of this PSLV is 44 meter. Height of GSLV is 49.13 meter. And the diameter 2.8 meter, and it is of 4 meter. And the payload, weight of particular satellite, payload, that is 1750 kg to sun synchronous polar orbit. For GSLV, that is of 2500 kg to geotransfer orbit. Or it will carry 1425 kg to geosynchronous or geostationary orbit, or 5000 kg to low Earth orbit. Next parameter is first flight. When they are going to launch a PSLV. First PSLV is on September 20, 1993. The first PSLV has been launched on September 20, 1993. That is, first PSLV has been launched. And the first GSLV has been launched on April 18, 2001. April 18, 2001. And total launches, total number of satellite has been launched in PSLV is 39, and the GSLV is of 11. And recent launches, Cartosat 2 series satellites, that is launched in February 25, 2017. Chandrayaan 1, October 22, 2008. Next, Mars orbit. Mars Orbiter Mission, Mangalyaan, November 5, 2013. Astrosat, September 28, 2015. And GSLV, the recent launches is GS 1819, that is launched in June 5, 2017. And next GS 89, May 05, 2017. And next GSLV, that is launched in INSAT 3DR September 08, that is 8, 2016. This is what a comparison between the PSLV and GSLV. You have to remember this. What is actually meant by launchers? How many types of launches are there? They have mentioned last minute. That is, what is launchers? What is meant by satellite launch vehicle? A rocket that can be used to launch a satellite. A rocket that can be used to launch a satellite is called satellite launch vehicle. That's made up of 4 stages. First stage, second stage, upper stage, fairing and satellite. We have seen the first stage is it has to carry the satellite from Earth to the sky. That is the actual function of satellite. Once it reaches to the sky, the first has been burned up. Second stage, it has to take the satellite from sky to the space. Once it is reached to the space, all the fuel has been used up. It is burned off. Upper stage, it is connected to the satellite itself. Once it is connected to the satellite, it is going to protect the satellite through the fairing. Once it is reached to the Earth atmosphere, and the third stage has been burned off. Once the third stage has been burned off, an actual satellite is start revolving around the orbit. Once it is start revolving around the orbit, it has to open up its antenna, communication antenna and solar panels and start giving the communication to the public or to the Earth station. 2 types of satellites. One is BSLV launch vehicle and GSLV launch vehicle. You have seen the comparison of PSLV and GSLV. These are some of the numericals. You have to see the point number 8, last point of this unit. You have to see some of the numericals on Kepler's law. You have to see the numericals on Kepler's law. You have to write these 2 formulas. You will see the numerical in next lecture. Numericals on Kepler's law. You will ask the question, if the orbit is elliptical, the equation is, the equation is T square, write it. Those who are not understanding my handwriting, write it. The orbit is elliptical, the equation is T square equals to 4 pi square AQ divided by mu. T square equals to 4 pi square A cube divided by mu for elliptical. If the orbit is circular, the equation is T square equals to 4 pi square, T square equals to 4 pi square R cube divided by mu. T square equals to 4 pi square R cube divided by mu. I think you have written these 2 equations. Take one numerical. The first one. A satellite is rotating with the orbit time of a satellite is rotating with orbit time of 12 hours. 12 hours. Calculate orbital radius and orbital velocity. You have to calculate the radius and velocity. This is the homework for you. What you have to calculate? First, you have to convert that hours into seconds. That is time. He has given 12 hours. Converting into seconds, you will get 12 into 3000 600. You'll get a time. For circular of radius, for the circular of radius, you know that is circular of the radius, that is in circular, t square is equals to equation is 4 pi square r cube divided by mu. You have to calculate the radius of that particular orbit. R is equals to, you will get particular value. You have to calculate same the velocity, the speed. The equation for this velocity or the speed is, write down this, v is equals to, in bracket, mu divided by r naught whole raised to 1 by 2. Mu is equals to, v is equals to, in bracket, mu divided by r naught whole raised to 1 by 2. Calculate this. This is your homework. Write down this equation, these three equations. Numericals on orbital parameters. Numericals on orbital parameters. Write down the equations which are numerical in next year. First, orbital speed equation. For orbital parameter equation is, for orbital speed equation, v is equals to square root of g into m center, that marks earth gravity and mass of the earth, g into m center divided by r. That is to calculate the orbital speed. Next, orbital period. Next is of orbital period. T square divided by r cube is equals to 4 into pi square divided by g into m center. Write this equation. Orbital period equation, t square divided by r cube is equals to 4 into pi square divided by g into m center. Next, acceleration equation. Acceleration equation is a is equals to g into m center divided by r square. G into m center divided by r square. These are the some of the equations to solve the circular orbit and an elliptical orbit. I think you are written, and in next lecture we'll solve some of the numericals. Start giving your attendance. Everyone has to give attendance.